Complex computer viruses that are specifically designed to disrupt or destroy infrastructures use domain knowledge to hide their malicious activity inside the content of network traffic. Network analysts are forced to analyze traffic using deep packet inspection and automated network intrusion detection systems. The result is that analysts are overloaded with hundreds of alerts and attributes in which they have to find the ones that are relevant for their investigation. In this video, we present CoNTA, a novel exploration method for network analysts to investigate network traffic content using alerts, attributes, and interaction as central elements. The system CoNTA consists of 4 components. The timetable enables experts to inspect trends and outliers in a single attribute over time. Color can be used to inspect value distributions in greater detail. For the discovery of relationships between attributes, an attribute viewer is introduced, showing the frequency and distribution of attribute values in the network traffic as scented widgets. Histograms on the left show the distribution of attributes according to all the traffic, while histograms on the right only focus on messages classified as malicious. This enables experts to see that most alerts were generated at the end of our time period. Bins can be adjusted and deselected for creating more specific queries. The context view enables experts to store message collections they are interested in. Storing a selection as a new context results in a new attribute that can be inspected using the attribute viewer. The conversation view shows the frequency and ordering of attribute values inside network conversations. A conversation view based on MAC addresses showed that 3 hosts were involved in the burst. Let's investigate our burst in greater detail. Experts can assign attributes to the timetable axis to inspect and compare trends according to certain profiles. This enables experts to, for instance, inspect traffic on a per-user basis. The legend in the corner shows which attributes and access ranges are currently chosen. Attributes can be sorted and filtered to discover correlations between attributes. Hovering the mouse over visual elements enable experts to see the impact of a selection before applying it. For the individual inspection of messages, experts can switch to a pixel map, showing every message in the current context as a single rectangle. Messages in red are classified as malicious. We can refine the classifier by switching to a second set of histograms, showing the number of times a value was marked as an alert. Selecting all bins in the histogram shows all locations where duplicate IP values were detected. Hovering the mouse over a message results in a pop-up, showing all normal and malicious message values. Coloring the messages by IP address reveals that there is one host using 2 IP addresses at the same time. For the refining of alerts, we can use the same widgets to filter, bin, and select specific attributes for classification. This immediately updates the visualization. Alternatively, alerts can be removed using self-training. We go back to the first context and select our conversations only containing Modbus traffic. We can do this by searching for the protocols attribute and exclude other values using the range slider. Next, we select all alerts that were created by the user with the most alerts. Filtering the fields by Modbus and sorting attributes by relevance shows that different registers are involved. Grouping the traffic per register while inspecting the register values shows that the values are altered during transfer. To enable better comparison between contexts can be put on top of each other. Now messages can be analyzed with respect to the access of the ancestor context. This reveals that the router might have leaked information to other hosts during the attack. In the Office network dataset, we sort on most alerts and see that a lot of alerts were caused by rare file names. We first create a context only considering messages that involve file access. For the comparison of attributes with many different values at the same time, a heat map visualization of the attribute is preferred. Access can be ordered and rescaled using the options menu. Here we can see that a few hosts in the network are working during day and night. We can see that many alerts were generated between 6 and 7 AM. A conversation view based on file names shows that besides strange question mark values, a logon file was shortly accessed after a logoff file. Selecting the edge reveals that 2 users were responsible for the sequence. Selecting the cells and sorting them by alerts shows that many messages have an odd message flag. Selecting the flag values and sorting them by relevance shows that most of them are coming from 2 MAC addresses. This is interesting since we have selected more than 2 IP addresses. Switching to the pixel map and coloring the messages by MAC address shows that the users in the subnets 4 and 5 are all originating from the same host. Inspecting the alerts in a tabular view indeed shows that some suspicious files were accessed. This concludes the presentation of CoNTA. a new approach for the investigation of network traffic semantics using alerts, attributes, and interaction as central elements. Thanks for watching.